So welcome everyone to the to this session about the methodology and tools for ontologies, and we're shuffling a bit the schedule, and we're going to start this session with Dermot, who is the CEO and co-founder of Dinaccurate Shell. Yeah. An artificial intelligence-based company focuses explicitly on semantic interoperability for complex data in critical sectors. And he's going to talk about mappings. So, Dermot, the floor is yours.
Thank you very much. So I understand I'm here for 10 minutes today, so I've popped on my timer to be disciplined. Yeah, this is going to be partially tongue-in-cheek, and also understand I don't come from the data science background. I come from the business side. So to be honest, my presentations are always going to be more focused on that kind of, if you say, pragmatic side of things when it comes to the market, etc. But also, I suppose, for those people who have to work around ontologies and taxonomies, etc., and are maybe, like me, relatively new to it and not nearly as expert as other people may be, you know, I'm going to try and make it somewhat humorous. So if you don't know these film references, it means that you're much younger than me, and therefore I don't respect you. But take it from me, these are classics from many decades ago. So the future. In the future, we'll have more information about the information about a thing than we have information about the thing. So I hope that's kind of either sending you to sleep or waking you up after the coffee. And now I'm going to get a little bit more serious on that. So you see the information about the thing. Let's take a box of drugs or the reference to the film, The Thing. The information about the thing is literally what it is. In this case, ibuprofen, 400 milligram coated tablets. And then the information about that is the metadata, the mappings to other databases, for examples, labels, which we may want to add on that, and other relationships. And that's not even an exhaustive list. And all of those things are going to change. And then there is the good news and the bad news. And this is where it starts coming, I would say, pretty serious. Oh, my mistake. Starts coming pretty serious. The thing and the information about the thing should be static. Okay? And because you're looking at a primary source here, and when the days back when I was doing research, and it's more important even now with misinformation, to know that the source is to know that the primary source is accurate is the kind of inviolate description of whatever subject you're talking about is tremendously important and becoming more and more important now, because it's getting very, very difficult to absorb the information as fast as we would like. And still be confident that that information is accurate. And of course, you only have to look at the news media or look at things like Wikipedia, where you have a huge amount of bias or just an inability to explore as much, or just not enough resourcing to get to literally the truth, to start understanding how difficult it is to know at times whether you're actually looking at the primary source, or another way is we're putting more and more trust into intermediary sources of information purely because it's less time consuming. The bad news is that information about the thing is never, ever, ever going to stop changing or expanding. I made this point before. I soon just coming up to 3 minutes. We will all have health records, and in the future, those records are going to be much more accurate, much more interoperable, and just a hell of a lot better than they are now. So think about into the future, you know, maybe 10, 20, 30 years from now, and think about having pretty good, pretty interoperable health data. And if you had a dynamic semantic layer, which was always, you know, keeping that information up to date, which is the nirvana, why would you ever throw that information away? The subject is dead, you know, so there shouldn't be that many issues with it, or certainly less issues about accessing the data and exploiting it. But think of how much patient records you'd have over a century or 2 centuries in that environment. You're going to have this absolutely tremendous mass of information. But the only way to keep that going is that is what I have here in the first bullet. We need information on information to contextualize information over time, which means that semantic layer, which contextualizes the thing and the information about the thing, that will never stop growing, as I mentioned before. But there's huge value in maintaining that. So you start running into an economic proposition straight off. And this is where, because it's a dynamic layer, you're going to have, in my opinion, ever increasing technical abilities to manage it and ever increasing costs. Now, you could say, yeah, technology costs go down, but as things get more efficient, you get more desire to exploit, and then you have more desire to use, and you have more data in general. So I'm not really sure where that curve goes. Maybe one of you will have a good point on that. But what I'm saying is, from where I'm looking at the market at the moment, there's a natural limit on human ability to manage for things like mappings. Free tools are going to have a limit in capabilities due to expanding complexity and demands. You'll have an ever-increasing technology stack. And my last bullet point is actually hidden by something: requirement for simplicity for adoption. That's a big one, because the people who are going to validate mappings are not necessarily going to, in most cases, they won't be data scientists, in my opinion, if you're going to get to that scale. So, 1 second. Now, and taking ideas from university and bringing it to market is much more expensive than you think. I've shown this tool before in OntoCommons, so I didn't want to show it again because it would be repetitive for you guys. But any of you who want to explore that tool, this is literally a mapping tool. You will see a video of it online with cool music and all of that, and you'll see its capabilities. But there's plenty of cost in taking something like that out of the university and putting it out to the market. But at the same time, you know, it's necessary. So then you have another economic barrier. The people most likely to recognize the issues I've been talking about are the least likely to buy a solution, not because they don't want to, but because it's difficult to justify if you're on a 4-year project or something where you want some semantic harmonization, how much you're going to invest in that. You know, you'll probably just do it manually, and that's quite okay and totally understandable. The people who don't understand the issues, you know, and who should buy, I'm afraid, are a lot of the public sector, because they're not data scientists. And that's, again, it's not a criticism, and they have a lot of things to deal with, but that's the reality. And the one sector that can do it is the pharma sector, because they have both the people and the money. But their use cases aren't necessarily transferable, but they're also, you know, probably one of the best resource industries on the planet. And now it's taking on new dimensions because of the growth of AI and also conflict, I'm afraid. And we have to balance the semantic layer, which can be based on authoritative ontologies and vocabularies and their related mappings, is what I would describe as part of the architecture of truth. Okay, and this actually came up earlier this week because I was on a trade mission to Ireland. I'm still sitting in Ireland, but I was coming from Luxembourg as part of their delegation. And I was asked specifically about this, you know, how do we combat, you know, let's say more rampant use of AI, and particularly where we, you know, going to start relying on AI more and more, and also the general kind of security aspects of that. And I talked about this architecture of truth and the necessity of being able to rely on authoritative ontologies and their related mappings, essentially as a chain of the architecture of truth. And the example I was asked about was an individual, I think it was a young man or a teenager who had set up a company. He'd used, I think, ChatGPT to set up an organization and promote a blockchain investment, and the company had been valued at millions, all within the space of 1 or 2 weeks. Now, I didn't actually get to validate that story, but that was the one that was pitched to me as an example. And even if it's not, you know, totally true or not totally true, as I have explained it to you, we can use it as a thought experiment. And the first thing I came back with is, well, okay, if he set up a company, where was the company registration number? And isn't that registration number supposed to be in the public domain and properly seen? And I'm not really sure if you can set up a company without signatures and things like that. Maybe you can in some jurisdictions. But my point is, you'll have identifiers, and you're going to have a lot of identifiers, even for, you know, one thing. We talked about the information about the thing. So those identifiers presumably are going to be from authoritative sources. And this is how we combat misinformation, but also possibly an over-reliance on AI. But I suspect in the future we're going to have to introduce it more to the education system. And here's the solution, or a solution question mark. If ontologies and their mappings are so fundamental to truth, shouldn't we make the argument that they deserve significant public sector investment? Yeah, I mean, I personally think so. We already have it at the Publications Office of the EU because they have to have, manage quite a few of these vocabularies at European level so that our legal rights are protected between different countries. You also have the Connecting Europe Facility terminology servers for health, which are just going to get bigger and bigger. And then you'll have terminology servers right across health and life sciences. These are supposed to be ensure the propagation of authoritative sources, right across industry and society. And I just say I'm just getting to my 10 minutes, but I promise I'll be finishing now. So you need tooling for large-scale adoption, okay? And I mentioned before that this semantic layer is it's never going to stop growing. It may not be as dynamic and large in different areas, it may be more static in others, but I can tell you in the life sciences, probably law and administration is just going to keep growing and growing pretty fast, Now, if you look at it like that, I'm not really sure how much you can rely on tools coming from communities, etc. I would start making, but don't get me wrong, I'm not saying give up ideas, give up concepts for that, because they're absolutely necessary. But I am coming around to the conclusion that there needs to be huge public sector investment in this, simply because it is required for the new economy. Because these sort of technologies actually create the fundament for the development of more AI. And of course, we want these things to be beneficial for society. So at 11 minutes, I'm going to stop talking now, respect for everybody. I'll stop sharing as well. And if that has stimulated any interest from anybody here and wants to ask a question, I'm all ears.
So thank you very much, Dermot, for the interesting talk and keeping on time. Perfectly. And let's see, is there any question in the room? Yeah.
So I've addressed some of the issues you just talked about now at various points in the meeting, and you brought them into the foreground in a very nice way. I agree with your recommendation. I agree with what the solution would be. But having spent 30 years teaching people how to build ontologies, I know that the solution will not be easy, put it that way. First of all, the number of people who can do it well is very small. And it's not clear how we train them. And what is clear is that this will only work if there is a very powerful control on what they do. Because we want trustworthy ontologies.
Yes, absolutely.
That you need powerful, forceful, punitive agents who can marshal the teams.
Yes.
Otherwise, they'll just drift off and do the easy thing.
Oh yeah, absolutely. I couldn't agree more with you. This for me has to be fabric of the public sector supported fabric of truth, but because it's so fundamental to our society and future services. So I couldn't agree more with you than that. It probably means you're going to see mapping validation, I would hope, as a pretty full-on endeavor for a lot of people. But I also think it can be distributed much better as well, and we can reuse authoritative mappings from other people. So we should try and get rid of the repetition as much as we can.
Yeah, you're a bit more optimistic than I am.
Yeah, it's because I'm trying to sell it. That's why.
Okay. Is there any other question or comment? I didn't see any in the chat, right? Okay. So thank you very much, Dermot.
Thanks, guys.
Nice to have you around. And maybe we go for the online ones, or sorry. Okay. Did you have Claude presentation? Okay. Then next speaker will be Claude, and sorry for the pronunciation, Fauconnet, main author of and developer of Sous Lessons system that we are going to see, and he works for Total Energies.
I used to work for. I used to work in Total Energy for many years. So I come from industry and industry view of things. It's not different from academic view of things, and I think it's complementary. And I work for Total because I'm retired from Total. So I work for Total. So why did I do Soulessence? In fact, I was very interested in data. I was very interested also in semantics, in philosophy. I was interested in IT technologies that I practice for new technologies that I practice for 20 years. And I saw a lot of frustrated people from data management in Total and in industry because they still spend time, most of the time, to look for data, to try to understand what the other says, and to share Excel files and so on. And so I was interested in ontologies. I was interested in data management and also in visualization. I used to be a geologist, and for me, the maps, the visualization is very important. So this is the reason why I work in this area and develop this tool with colleagues, working colleagues now in Total Energy, and Jean-Charles Leclerc, who some of you know him, which is very active in this domain. He contributes to standards, to many standardization organisms, and he is convinced that ontologies are the best way to deploy and to use standards in the industry. So we work together to create this tool. And the concepts are that ontologies they have a graph structure, and we are convinced that graph structure has to be visualized as a graph, in fact. Okay, because tabular representation of or linear tabular textual representation of a graph, it's not so obvious. In fact, you have a you don't have the overview of what you are doing. You have to also to be able to navigate into the ontology, because you have many complex information linked, and you have to be able to navigate in a nice way in the graph. You need to be able to query the ontologies also, and also the data depending on the ontologies, the individuals that are linked, because the ontologies themselves are nice to semantize the domain, but the one of the goals for industry is to link them to the data, and to link. What we want to do also is to link data and knowledge. It's very essential for industry to link data and knowledge. And so we believe that we have to modelize knowledge into ontologies and be able to link data behind. Sometimes transforming data into triples that we can query with SparkQL, or also in making linking ontologies to data in a tabular format in SQL database. We also have to use nice features of ontologies like reasoning and rules and so on. That's why we did this tool. And we have some success now inside Total. It's not Energy, it's not, and other places like here, and even outside. But it is not so easy to convince people, management, because middle management, top management is okay, but middle management in industry, they are afraid of. They work with Excel files and tabular data since so long that they have difficulties, cultural difficulties to move on the graph and to move to complexity, in fact, to management of complexity. So Soulessence is based on some technologies. It's an extensible platform. We are now it has a strong basement, and we can enrich it. And it's done to visually manipulate, compare, create, enrich ontologies and knowledge graph. It is a free open source It's non-profit. It has an MIT license and it is available on GitHub. It is based on, it's a web application based on Node.js and W3C standards. It has, it uses some visualization tools, very nice visualization tools, which is called VisJS, very powerful and well documented. We have some SparkQL engines and inside or outside solutions. We use Virtuoso by now, but we can use any other SparkQL database. We have also Elasticsearch engine inside because it's more convenient to query from the labels with Elastic than making regex into SparkQL. We are also introducing in the platform Java APIs like or software like Jena, All API, and RML.io. We will also integrate. I don't remember the name. To make some SparkQL to SQL on top engine also. We are doing this with people working in the students working in TARB with Arco and Eddy. Okay, that's about the architecture of the product and the ambition, as you see, like the little Petit Prince, is to draw ontologies. In fact, we want to do this. And in fact, we draw them at different levels. We start from, we began to, at the beginning, we just wanted to be able to do domain ontologies, like to modelize a domain based on an upper ontology. And so historically, we started with ISO 15924 because it was the one we were linked to with total activity. So now we open to DFO and to Dolce and so on. And we since more than 2 years, 3 years now, we are developing the tool and the application of the tool with many data in data domains in total energy. And since we work with OntoCommons and Enit in TARB, they asked for features to manage upper ontologies. And so we added a feature to be able to edit axioms and to visualize axioms and to edit axioms also. And we began also to introduce new features linked to the ontologies themselves, to the upper ontologies. And at the bottom also, we began to work a lot to be able to manipulate data from the ontology. So we introduced interesting features like bags, RDF bags, because it is orthogonal to semantics in the ontology. Graphs are very practical in real life because in real life, you want to mix things that has nothing to do together semantically. There are different things. And with this notion of containers and bags, you can make collection, aggregate of heterogeneous objects, which is very practical in real life to describe object, any kind of object. So we mix the semantic view wrote by ontologies and with the composition view wrote by containers and so on. And we have making a lot of experiment in this, and people, it's working nice. So we have feature also to manage data, and we also work on linking ontologies to data, and I began to do it with a system to map the classes and the relation between classes expressed in restrictions, to map them to some relational data models and to be able to generate SQL. So I did a first version of this, but we will work with a student from Brazil, with Mara Abel student. He will work on using OnTop technology to be able to generate SQL queries in many different sources from the ontology. So this is what we need in our industry, in fact, because all the industrial data, they don't need to be put into triples. So if we want to valorize them, we have to be able to query, to have a upper level, semantic level to query and to execute the data into the native storage. This is what we are trying to do. We have capabilities in this tool to visualize not only, as you see here, here you have some visualization of the graph, okay? But we are also able to edit the data, to visualize the data, all the data, also to make some queries with advanced query generator, SPARQL query generator. And also, we have some editing capabilities. We are introducing, as I say, reasoner and rules, and so on. And after that, this is the architecture of the platform. We have it's a web application with a internal SPARQL server but we can also query external SPARQL server and mix the data together. We have a search engine. We are able to connect to some SQL server, any SQL server, in fact, to as I told you before. And we introduced what we called a JOL server, Java OL, which is an open source platform also that exposes APIs to call Jena or all APIs features. Okay, and this is a web application. Okay, and at last, I have another slide, the last one. As Arco said, it is now integrated, not all the feature, into industry portal. You can call it from industry portal. And you should be able to see any ontology that is in the industry portal into Solutions. And you have the contributors. We have some partners from Total, Enit, OntoCommons, Logilab, which is a software company, and I have created a company. But we will. The most important thing is that we are creating an association, non-profit organization, to make these concepts to upgrade the application, and also to be able to provide an online service for Solutions for people that want it. Okay.
So thank you, Claude. I didn't see any question online. Is there any question in the room? Otherwise, I will have a. Okay. No online. Okay, so as you said, the code is open source and it is available. So which skills or knowledge should I have for profiles in my team to get that running?
Okay.
So which are, if I want to run the system, which profiles or skills do I need to have?
Which
knowledge or which kind of profiles do I need to have in my team?
Okay. It is not done for specialists that like to work with protégés, but people that know nothing about ontology that are not interested. But you have just people with interest in ontologies that want to be able to manipulate them without going into protégé, because protégé don't like it at all.
And for installation?
No, in fact, installation it is in Docker installation.
Docker.
It's so quite easy, but you have to be IT anyway. But that's why we will offer an online service with not much money.
Okay, thank you. Any other question?
Okay.
So-
No money, just the one. No money, just to play with the one.
What?
No money, just one. One.
Andrea, can you start sharing your presentation?
Sure thing. So I'm going to turn on also my video.
Okay, we see you.
Okay, I think you should see my screen as well.
Perfect. Okay. So now with us we have Andrea Chimino, an assistant professor from Universidad Politécnica of Madrid, and he is an expert on the semantic interoperability, linked data, data integration, and IoT discovery. So Andrea, the floor is yours.
Thank you, Maria, for that nice introduction, and thank you for inviting me. So today I also turn on my clock to be on time. I will be presenting a tool we developed that is called Astrea, and basically it automatically generates shackle shapes from a set of input ontologies. So as you know, knowledge graphs have been growing in the last decade to numerous numbers of data sets, and all these data sets somehow follow the structures and the restrictions or constraints that some ontology defines. And as these data sets have growth in number, as well have done the different ontologies. A lot of them have been developed in order to fulfill the requirements of a very wide range of domains. So the question is, now that we have this large amount of data and we have all these ontologies that somehow describe some restrictions, can we validate that the data is correct according to the ontologies? And this is precisely what the shapes allow us to do. The problem is that we will need to do a lot of shapes in order to validate all this data. And this is the main problem we try to address here. So how we can validate and generate the shapes, right? Well, there are several proposals for the validation of RDF versus some restrictions. In our case, we focus mainly in the shackle because it's the W3C recommendation, but I mean, there are others as well. The first approach to generate these shapes is manually. But the problem of manual generation, as you can imagine, is that this task is quite complex. Restrictions can be really complex and therefore error prone. It usually requires a deep knowledge of the domain, which is something that usually in the ontologies is already expressed somehow. And also the data models can be very large. So you can have an ontology that is very large, and expressing all the shapes, again, can be a very complex task. Due to this reason, a lot of researchers have proposed tools to generate the shapes automatically from the data. The problem with this is that since we do not know if the data is actually correct, if we learn shapes from the data, we can end up having wrong shapes. And that's not something we want. So in this work, what we propose is that we take the ontologies as input, and with those, we will generate the shackle shapes that later can be used, of course, to validate the data. And for this, we propose the Astrea system. Now, how we generate these shapes from a given ontology? Well, this is the bottom line idea here. And as you can see on the above side, you have an ontology pattern that basically states that something that is an object property has a range, right? And this somehow is a restriction we can translate to shapes. And you have the equivalent version in shape in the part below of the slide. So as this pattern, old pattern, has been translated into a shackled restriction, there are tons of them. How we know this? Well, in order to actually do this work, we did a lot of research on OWL and shackle, and we design a kind of mappings that allow us to, given the ontology, translate and retrieve these shackled patterns. And well, we develop by hand 158 mappings, which you can actually check and have a look with these URLs. It's published in Zenodo. And also we have here data portal with a Sparkle endpoint, so you can just query the mappings. Digging a bit more in the details, this mapping basically hold an equivalence between an old pattern and its equivalent shackle shape. And how we implemented these mappings? Basically, they are Sparkle queries, construct Sparkle queries that query the ontology, retrieve data, and construct the shape pattern. All these are, as I mentioned, stored in this knowledge graph, and they follow this ontology. That you can see here basically is what I mentioned. The mapping has a pattern that relates a shackle pattern with an old pattern through this construct query. Okay, you can see here the example we were discussing before, in which we have the old pattern, and on the right side we have the shackle equivalence, and the query we need to run is this one in yellow. Okay, so basically with these mappings, having the ontology, we can build the shapes. Now we need to say here that these mappings are only in one direction, so we cannot go from shackle to owl, even though that would be interesting. Now, okay, we have done these mappings, we can generate the shackle, but is this good? Is this complete? Well, here you have a table in which we sum up all the restrictions that you can define with shackle shapes, and all the green ticks are restrictions we can generate from the ontologies, and the rest we cannot do them. But before deciding if these ones we cannot do is something that is actually a lack of our tool, we perform an analysis of these restrictions. And actually, well, here you have the statistics. Basically, we generate or we cover 60% of the shackle, but from the rest, that was what I was mentioning, almost 20% are data value restrictions, which are agnostic from the ontology, and therefore we don't have anything in the ontology to learn these restrictions. So actually, it's not feasible. But this, for instance, this restriction could be interesting to be learned from the data. Then the 30% are actually restrictions that they really depend on the domain and on the practitioner preferences. So it's also something we cannot automatically choose for the user. And finally, the 5% is a restriction we cannot directly express because we cannot have a mapping for it. So and now, okay, we have this tool, how it works, right? Well, as I was mentioning, we have a set of ontologies. The tool will receive one URL of the ontology. It will retrieve that ontology or the referenced ontologies. So if one ontology imports others, those also will be retrieved. Then these ontologies the code will be sent to a knowledge graph manager that will read the mappings and apply the different mappings to these ontologies. And finally, it will give you the shackle shapes. Just to give you a very quick, because I'm finishing my 10 minutes, a quick view of some experiments we performed. We took several standard ontologies like Saref, Time, Saref for Envy, SSN, also some ontologies we developed in European projects, and the DBpedia ontology that you probably will all know, right? We use them to feed Astrea, and then we get the different shackle shapes for these ontologies. Well, the first thing we analyzed was the generation time. You can see here that it took, for most of the cases, around 1 second, 2 in the worst case. For I think it was this one was Saref. And here on the top you have DBpedia, that is the largest one, and therefore it took like mostly 5 seconds. But I mean, the shackle generation is not something time that requires critical time to be generated. So I think these times are okay. We can assume it. We can assume them. Regarding the restrictions, these are the numbers of restrictions we generated. I'm not going into the details, but basically we had relatively high numbers in this one, highlighted in green, and relatively low numbers in these ones. This is not because of the algorithm, but just because of the restrictions specified in the ontologies, that maybe they were not there, and therefore we couldn't generate the shackle shapes associated to them. Now, a very quick, in the case you want to use Astrea, this is an online service. You can access it through this link. And then, as I was mentioning to you before, here you can paste the ontology URL. You can actually paste more than one, or choose a file and then click generate shapes and Astrea will generate it. Or you can use our REST API or directly download the shapes from our catalog that it's also online on the same data portal. Well, in conclusion, shackle shapes are endowed for providing validation mechanism, and I think this tool really help us to create all these shapes for large set of knowledge graphs that are expressed with the ontologies, and of course that we cannot generate these shapes manually. And well, I already mentioned that we cover most of the shackle restrictions, 60%. And we already saw why we don't cover the rest. And to finish, the interesting enhancements would be to combine Astrea with other proposals that learn shapes from actually the data. We will need to see if these shapes from the data are correct or not, but I think it's still interesting. And also another interesting thing from the ontology engineering point of view is to have round trip mappings. So I have the shape, which ontology pattern I'm generating. And I think this could be also used for checking somehow ontology quality and other aspects of already built ontologies. I think this is it. Many thanks. Sorry if I was a bit quick. I didn't want to to end more late than expected. If you have any question, I will be more than glad to answer.
Okay, thank you, Andrea, for your talk. So I don't see any question online, but to be honest, I don't know if I look at the right place, but we have a question here. Umut?
Can you hear me, Andrea?
A bit low, but yes.
Okay, I come a little bit forward.
The questions are only here.
Yeah, here, right?
But some of them
I am Umut. By the way, nice to meet you, kind of in person, because I know your name obviously from papers. I'm from Umut from Innsbruck, maybe you probably also know. Just have a question. You said there were some feasible, unfeasible shapes, right? I just wondered if you had any examples of those on top of your head, because I didn't really understand why data type restrictions would be feasible to convert to shapes, because you could convert them to data type property value type restrictions, right? In the shackling.
Well, to be honest, I don't have right now one in my mind. Let me check very quick my table. But for instance, some of the restrictions are like flag or let me check values less than. So for instance, if you have age, right, and you want to say that a person must have an age above 18 years old, that's something we actually don't have in the ontology, or well, at least we were not able to have in the ontology, and therefore we cannot generate a shape for that value.
I mean, technically, yes. I think I didn't understand what you meant by data value. Now it's clear. But technically, maybe you can even try to do like a swirl generation based on that, if you want to also include them later in terms of implementation, right? Because semantic rule language, for example, I don't know if anyone is still using it, but if you want to, for example, extend it towards that direction, also support this missing ones, you could technically generate swirl. But okay, now I understood. Thanks. Yeah.
Thank you.
Thanks. Is there any other question? No, so thank you, Andrea, and well, now I'm going to introduce myself, and let's check first. I can share from here, but then I speak there,
yeah,
right?
If you're muted here, it's
I'm muted there. Okay, so
it's, this.
no,
Don't worry. I thought it was behind.
yeah,
Okay,
fine. That is fine. Okay, so I will start my timer as well. So I'm María Poveda Villalón. I'm also an associate professor at the Universidad Politécnica of Madrid, a colleague of Andrea, and I'm also part of OntoCommons. And now I want to present very briefly some resources that we have from OntoCommons, some deliverables you can check. And if there is time, I will make a very quick and short demo. So, what is OntoCommons providing to the beginners or newcomers to the ontology development? So people normally say, okay, I don't know where to begin when building my own ontology, and we say, yeah, there is a lot of information out there. You just need to process all that and choose what fits better for you. And this is just not even all the methodologies that we know are there. There are others also in the deliverables, plus best practices, plus blogs, plus recommendations from the W3C or other community groups. So there are many things, and now people feel overwhelmed. There are too many options. Okay, so we took what we think it is more useful in most of the cases, not always. Like, okay, you can take competency questions from Gruninger and Fox. We have the intermediate representations that I think they were great from methodology, but that was oriented to frames, so not applicable anymore, but you can save that. Then for sure go to the guide 101 from Natasha Noy, but still was oriented to frames, but very useful even today. And yeah, the collaborative process from Diligent and the scenarios from Neon. You cannot manage all the methodologies, so we make a Frankenstein in the link open term methodology, just giving you the pointers that we think are more useful in our experience, and also trying to move towards agile methodologies and trying to fit our development within the software development so that they take about us every month and not at the end of the projects. So in deliverable 4.2, you have these resources, and I didn't mention, but the LOT methodology includes the publication phase that was not really taken into account in the previous ones. So deliverable 4.2 for this information, and if in the paper that you also have there is open access, you can also find pro tips, things that we say, okay, we did this mistake so many times, don't go there, or go if you want to risk. And as I said, for each phase, each activity points to resources, tools, other papers, or pointers to further information that you may use. And yeah, we have some examples of internal and also external projects using the methodology. And then when we have a paper from someone saying, I use the methodology in this way and this is my resources, then we link from our website so it can serve as an example for someone else. Yeah, and then the tool support. So it will be great. And now I know the process. I want to automate as many steps as possible. So as I mentioned in the methodology, we point to many tools, but we extended the result about which tools are available within OntoCommons. So we took the methodology, all the steps, all the work from the very early project, workshops from the project, and the landscape analysis on ontology engineering tools. And then we create this map saying you for each activity which tools are out there that you can use. And there is more information in deliverable 4.7, I think. This is just a summary of how many tools you can find for each activity, and also some tools or resources that you can use along the whole process. Yeah, just some examples. For example, the repositories, where to find ontologies, how to validate whether the ontologies are fair, how to visually draft the ontologies, or ontology editors that we have License there, and among others. Yeah, so more information about this in deliverable 4.6 and 4.3. Yeah, we have all the tools, we have all the pointers, and we always want to have everything together in one place. So let's see a small demo about this system, in which it's quite limited, because if you want to have everything in one place, you have to have already some result. So, but of course, you can also use complex editors as Protégé and Top-Plate Composer and so on. So this system doesn't keep you login or something, it's just one shot. Anyway, I'm going to show you. Let me. Okay, I can go here. Okay, this is the system, tooling.ontocommons.linkdata.es. And here you just say, okay, Widoco is for documentation, so you can select or unselect. OOPS is for ontology evaluation. I will not select OOPS because it is getting the server, when you get a post, it understands a get and it's not working by the web server. You can always use the online application. Themis is a system for testing requirements like competency questions, but in Manchester syntax. So you say, my sensor has to be a subclass of device, and then you have a test that say, okay, sensor, subclass of device, and you have your vet test for all your iterations. And Astrea, that Andrea just talked you about Astrea and generating shapes. So you may think, okay, for executing all these systems, I need to have an ontology, but maybe we're just having some diagram. I do these diagrams in Draw.io following a particular syntax that is close to OWL. And then, okay, I don't have any OWL code here, but I can generate it from these diagrams. And now you will have to believe me that that diagram is exactly this HTML document that I can just drop here. And they say, okay, I understood that you are not including a TTL file, you are starting from your diagram, then I will use Choke to generate some OWL file. And from that OWL file, I will generate the documentation, the test, and the shackle shapes. So yeah, Widoco, Themis, and Astrea. And you can plug, you can drop here like 10 ontologies, it doesn't matter. And then I click, and it is working. Something was downloaded. Okay, these resources, I can click in the resources, and then for the ontology I created, I have the Choke resource that it is the ontology null, and that ontology null was plugged into the rest of the, I have 10. That ontology null was plugged into the rest of the services. So this is the ontology null. As you saw, it was organization, university address, and 4 classes. And then we also have the Astrea shapes there. I'm not sure whether to open that with Protege. So I will do this way. Okay. So we have here the turtle for the shapes. And something very interesting is Widoco. I will show you that if you just open the index, there was a change in the browser, so you don't see the imports, but I have here Visual Studio so that I open the folder, downloads, resources, my ontology, Widoco, the one. If I open the index as my computer was a browser, loading, go live. As my computer was a server. And then here I have the ontology documentation for the diagram that we had. So it is a handy way to plug in all the tools that we normally use. And that's all from my side. If you have any question, I'll be happy to answer. Thank you.
Maria?
Yeah.
I don't understand. If you drop more files, does it treat them independently?
Yeah. So if you drag more files, you will have here one folder per ontology.
It doesn't try to.
No, it doesn't. No, it's not an OWL import. You know, if you. Yeah. Is there any question online?
Not online, no.
Okay.
Any other question in the room?
Well, I didn't saw this. Yeah. So when we finish, when you get your results done, then we link to industry portal and link open vocabulary suggesting you how to progress with your ontology, also to follow best practices for publishing, because at this point you just drag and drop the file, maybe the ontology is not yet published. And that is why we don't use FOOPs, because FOOPs needs the ontology URI working. Okay, so I think now we will have lunch.
If we have time.
Yeah, I think we would.
You have 15 minutes.
Yeah.
I'd like just to share 3 surveys with all of the participants in the workshop. So the first one is a survey that we have the University of Oslo actually created for the OntoCommons project, because you have heard many talks in the workshop about the LOT methodology, which is the key and a very core component of the toolkit. And we have demonstrators who have used LOT methodology to develop their ontologies, and we also have other projects outside OntoCommons who has used LOT. So we kindly invite people who have used LOT methodology to provide feedbacks on this methodology so that we can improve. We can find it doesn't matter you have good or bad feedbacks, pros and cons. We all want to take your feedback. So you can find the link to this survey in the chat. I think, can you see it, Maria, from your end in the chat? I think I put it. Yeah, I put a short link to this form. I can show it.
All 3 are there.
The 3 are there. Okay, perfect. Thanks, Anna. So this is the input that we want to collect from all the participants today for the validation of LOT methodology. So a second part, I want to do a very, very quick live survey with all the participants. So I'm going to switch to another tool.
Just learn the links you posted in the feed, so I cannot share on screen. If you need me to share on screen, I will send them.
That's no. So if you can scan this QR code on your mobile, or you can simply use your laptop and open the browser, and then in the browser you enter vvox.app/ and the ID, or you can just enter vvox.app and then it will ask you for the ID. And the ID is the 9 digits 167894478, and you can also find this complete address in the chat. I just posted in the on-air meet. And I only have 9 questions, very short live survey to get feedbacks on the first version of the roadmap regarding toolkit. So this is the first question I'd like to ask. We have presented 3 aspects, the gaps, the industrial needs, and the recommended action for the future on day 1. So the first question is regarding the industrial needs. So we have summarized the needs from industry into 2 parts, functional and non-functional, and you can find the detailed explanation under each of them. So if you think that this is a true industrial need, you can tap anywhere on the image and we can see that which industrial needs is more urgent based on the number that is shown on the image.
Small.
Or too small? Okay, so we think that the OntoCommons ecosystem toolkit should offering several functional services. So those functional services should support all the phases of ontology development, and also it should contain a set of components, and those components should be linked together, like what Maria just presented. The tools should be integrated into a system so that can support all the services that you want during the ontology engineering and use process. And as for the non-functional services, I think we need the toolkit. Oh, I can zoom in and zoom out. Oh, I don't know that. Perfect. So it should be very flexible, robust, has a very good user interface, very user-friendly interface, and should be collaborative as well. And very important, we should consider the FAIR principles, fairness into consideration. So I've seen, so it's quite, I think, distributed among the requirements. So many people have supported the non-functional parts. I guess it's because we have a lot of tools available so far, but we don't have a very, very good user-friendly environment which hosts all the tools. So yeah, thank you very much for the feedback. I will move on to the next one. The next one is quick. So it's simply, do you think the non-functional services or the non-functional service or the functional service, which one is more important? I feel it's a tie sometimes. I think some people think non-functional comes first, and some people think the functional service comes first. But I think eventually more people support that we should consider more functional services for the toolkit. But during the live results, I think sometimes there is a tie between them. So I think they're both very important from the feedback. And then it's open-end question. Is there any other industry needs that you think are important, and you can write the text into the text box? And we would like to collect any missing industrial needs that we have. Maybe it's not a good idea to rush people to fill in the free text box, but in the chat, you can find the entire survey on the OntoCommons website, where you can also leave your feedbacks to the missing industry needs. We have one interoperability and data documentation. Okay, this has been emphasized for several times. And then enough for the industry needs, we go for the gap. So we have grouped the gap into 4 categories. Each of them, I'm so sorry, the text is a little bit small. So if you support any of the gap, you can tap on the image. I don't know if whether we have two presenters today who has presented the shackle shapes regarding ontology validation. So maybe people think that this gap has already been filled in, so nobody have found the gap in ontology validation, which is good. I think people knows that there are existing shackle languages that they can use to validate the ontology. And most of the votes are on still limited tool support. And the other is integration among existing tools or tool chain. Okay. Next. Okay. The next one is simply rank 4 of the 4. Okay. So the live results shows we still have limited tool support. I think Cloud will be very happy to hear this, because he thinks that the solutions can provide some help to address these problems, and in need of integration, as mentioned before. Good. Okay, I will close the poll. So like the industry needs, I'd like to also collect feedback, any missing gaps that are not shown before that you think are important. Regarding both tools and methodologies. Or training. We will have a training on in September. Yeah. training. Yeah. We also have a prototyping live happening in parallel and during this workshop. So I personally got some trainings from Cloud about solutions. I think it's very, very helpful if you can have hands-on, sessions or training sessions on tools and methodologies. Integrating with other tools. I suppose these other tools means tools that are not for ontologies. Like the presentation, Jinzhi presented the integration, like semantic integration between multiple model-based system engineering tools. Okay. Treat ontologies as first-class citizens in development. Good point. Thank you very much. Okay. So I have 3 more questions, all about recommended actions in the future. Okay. You can tap anywhere that you think and you support this action.
Bless you.
Bless you. Okay, I see emphasis on user-friendly tool chain and reference implementation. I think this will be the training topic in September for the tool chain and the reference implementation. We received requirements also from demonstrator that they want to know more about the tool chain and the toolkit. So this, I think, will rank first in the agenda in September. And the second and the third maybe more about leveraging industry portal and ontology adoption. Okay.
All of it.
So the next one is to rank the three. I think I guess I know the answer based on the last question. So in the second version of the roadmap regarding the toolkit, we certainly will suggest to focus more on the user-friendly tool chain and reference implementation. And we have a timeline also on the website version survey that people can select, in which year you think this should be considered, in which year the other should be considered. So based on the results today, I think the first user-friendly tool chain should be considered first, and this is the most recommended actions from stakeholders. The last one is still an open-end question. I would like to have any missing actions that you want to suggest to us to bridge the gaps or to answer to industrial needs. And you can also leave the feedback in the survey on OntoCommons website. Okay, I think I will stop here and okay, I have benefits and successful cases. Okay. Lessons learned. Thank you very much for your participants. I do appreciate your contribution and feedback to the roadmap. I think I will stop here, and if I miss any replies, you can go for the link that is in the chat and provide more feedback and inputs to the roadmap. Thank you very much.
Okay, I think this closes the session. Thank you very much, Lan. And we will switch to the future of ILF, which can be reached through the schedule here and for the people in Oslo in the same room. Thank you.
Yeah.